Right, so for this example number 2, so we have here, allow me to read to you the problem number 2. The beam has a width of 300 millimeter and effective depth of 520 millimeter. The beam is simply supported over a span of 6 meters and carries a superimposed dead load of 10 kilonewton per meter, including its own weight, and live load of 20 kilonewton per meter. So assume F prime C that is equal to 21 megapascal and Fy that is equal to 345 megapascal. So determine the required stirrup spacing near the support. So use 10 mm vertical U stirrup with Fyt is equal to 275 megapascal. So use NSCP 2015. Okay, so let's uh, go immediately to the solution. Right, so palitan natin yung kulay class. Alright. Okay. Solution tayo. Right, so the first step here is for us to solve for the VU, right? So solve for the VU. So as you can see, if you're going to draw the uh, beam, so simply supported yung beam natin. And as you can see in the problem, uniform distributed load yan. So we have here the ultimate uniform load na ikakarga ng ating beam. So ang length ng beam natin as stated in our problem is 6 meter. So we're going to first need to get the reaction, no? So dapat merong reaction muna dito. So the reaction here, so this is, let's say, R1 and R2. Okay? So now, before we get the R1 and R2, we need first to get what is the load. Okay? Ano yung value or magnitude ng load na ikakargahin natin. So 15 NSCP. So 1.2 uniform distributed load. Okay? Na nanggaling sa dead load po natin plus 1.6 WL for the live load. No? So that's WU is equal to 1.2. What is the dead load uniform weight? That is 10, including its own weight. And then plus 1.6 times WL, that is 20. Okay? So what is the WU? So 1.2 times 10 plus 1.6 times 20. So we will have a 44 kilonewton per meter na WU. Alright? Okay. So next, ready na tayo mag-solve ng R1. So ang R1 dito is equal to, as you can see, it is symmetrical beam with the symmetrical loading. So obviously, R1 will have the half of the load. So that is the total load, that is 44 times 6. So kalahati mapupunta sa R1, so divide by 2. So we will have an R1 of 132. Right? So we have a 132 kilonewton. Okay? Alright. So next is, ang problem kasi dito, determine the required spacing near the support. So as you can see, sa provision ng code natin, okay, we can uh, get our critical section or the VU uh, at the distance, right? So at the distance from the what you call that, the face of the support, from the support, right? So I'm going to draw the shear diagram here. Yeah, so we'll shear diagram natin. Right, so we have here is the 132. Same here, this negative 132. Okay, so ang ating critical section is the distance, okay, from the support. So what is this distance? What is D? That is the effective depth. So we can say this is 0.52 in meters, no? 0.52. Okay. So ito yung center line natin. Okay, where we can see the zero shear. Yes, you can see here, that's a problem natin, no? So ito yung center line, zero shear. Okay? So kailangan natin kunin yung shear dito. Okay, ito yung ating gagamitin to solve the spacing. So VU. Okay, so to solve the VU by similar triangle class, so you can see, no? Okay, by similar triangle, we can say 132 okay, is to 3, right? So this distance to this, that is 3 meters. Okay, is equal to VU all over 3 minus 0.52. Tama? Okay, that is 2.48. Okay, so what is VU here? One o 9.12 ang VU natin. So 109.12 kilonewton. Yan ating VU. Okay, so nakuha na natin. So step number 2 is for us to solve the VC. So step number 2, dito ko na nalagay, is solve for VC. So VC, that is 1 over square root of 1 over 6, no? Wait lang. Okay. So 1 over 6. Right? Sige, wait lang. Yan. 1 over 6. 1 over 6 square root of f prime c bw t. Okay? Hindi ko mabura yung 9 doon. Yan mo na. So, kita naman, 1 over 6. So, 1 over 6 square root of. So, what is f prime c here? 21. Okay, bw, that is 300. And d is 520. Okay, so don't forget class to uh, solve or divide this by 1,000. No? Ayan, divide natin para maging kilonewton. So let's compute it. Okay, ang lalabas sa sagot is 119. So 119.15. Yan, 119.15 kilonewton. 0.15. Okay? So next, PVC. Okay, PVC. That's 0.75 times 119.15. So what is PVC? So 89.36 kilonewton. Alright? So dito, sa problem natin, kasi ang tinatanong lang naman class is the spacing near the support. As you can see, your VU is 109. This is greater than the PVC. Okay, so no need for us to get the 1/2 PVC here. Okay, kasi mas malaki naman yung VU. Ano? Kasi sa PVC. Yes. So, hindi siya magpo-fall sa minimum AV. Okay? So, no need for us to get the 1/2 PVC. No? So, diretso na tayo to solve for the VS. But, before that, kailangan natin malaman kung papasok sa cross-sectional dimension checking itong VU. So, we need to solve first this value. Yung dapat masatisfy natin itong equation na to. No? VU is must be less than or equal to phi, okay, VC plus 2/3 of uh, square root of F prime C BWD. Tama? Okay? Dapat masatisfy natin to. Okay, so to check that, we need to get the value of this. No, itong nandito. So, lagay na lang natin sa kabila dito. That is 0.75. Quantity VC. Okay, what is VC? 119.15 plus 2/3 of square root of F prime C, which is 21 times BW, which is 300 times 520. Okay, take note sa part na to, we need to divide this by 1,000. Okay, kasi itong VC na to na nilagay natin is in kilonewton. Samantalang pag hindi natin dinivide ng 1,000 to, okay, in Newton pa rin. So, dapat parehas sila, no? Before we add it. So, we divide it by 1,000 here. So, we will get the value of pakilabas na lang yung calcul nyo class. Okay, solve natin ng sabay. So 446, no? So this is 446.8 kilonewton. Okay, as you can see, our VU is only 109.12, which is less than the 446.80. So therefore, okay itong section natin. No need to adjust the section. So next is solve for VS. Yes. So, solve natin yung VS po natin. So, to solve that, from the equation, VS is equal to VU all over reduction factor minus VC. So, that is VS is equal to VU is 109.12 all over 0.75. Bawas natin ng VC, which is the 119.15. Okay, so 109.15, 0.12 divided by 0.75. Bawas natin 119.15. So we will have a value of 26.34 kilonewton. Yun. Alright. So next, after solving for Vs, spacing na po tayo. Okay? So spacing S. Right, so spacing S. So from the formula Vs is equal to AV FYT D all over S. Or pwedeng direct na tayo. S is equal to AV FYT D all over Vs. Okay? So ang AV natin dito, take note, the beam stirrup is U. Okay? So ito yung mga main bar natin. Ang beam stirrup natin is U-shape, no? Ganyan siya. Pasa natin konti. Yan. Okay, so U-shape. So U-shape to, may hook ng ganyan. Then may hook. Alright? So dito, ang AV natin is yung makakat na legs. So this one, no? So we have 2, okay, times area of the stirrup. That is 10 mm yung ginamit na stirrup. Okay, times FYT 275, no? Okay, ito yung given natin, 275 ito. Hindi po ito ang gagamitin na. This is for the main bar. Okay, dito tayo sa yung strength ng stirrup, 275 times D, 520. Okay, let's divide it by the VS. Ang VS natin is 26.34. Okay, times 1,000 natin. Kasi dapat naka-Newton to. Kasi naka-MPa millimeter square itong ating value sa taas. Ano? So, our S here, okay, will have a value of, yung units nito naka-millimeter na to, no? Okay, naka-mm dapat yan. Kasi pinalitan natin ng Newton and then millimeter yung mga value natin. So, we have 852.79 mm. Let's say 850 mm. Okay? So the question is this the answer for example number 2? Okay? Okay, pwede na siya, but, okay, pwedeng siya yung answer, but, take note, we need to check first sa S-max. Okay? Dapat pumasok itong 850 sa ating X maximum spacing po natin. So, nakadepende yung maximum spacing natin sa ating VS. If our VS is less than the 1/3 square root of F prime C BWD, you will have, ano ulit yun? D over 2 or 600 as your maximum spacing value. So, check muna natin kung ano yung magiging value nito. No? So, that's 1/3 square root of 21 times BW 300 times D 520. And then, don't forget to divide this by 1,000. So, what is this value? So, 1/3 times square root of 21 times 300 times 520. Let's divide that by 1,000. So, that's 238. So, this value is equal to 238.29 kilonewton. Which is obviously, ang VU natin, or ang VS natin, which is 26.34, is less than this value. No? So, 26.34 ito. So, less than siya. So, we're going to use D over 2 or 600. So, paki-compute mo na to. That is 520 divided by 2. That is 260 mm. Then, the other one is 600. Constant na 600. So, Sa S-max natin, sa code, yung pinakamaliit po ang pipiliin natin as your maximum spacing. That is the 260. Now, we compare it to our S. Our S is 850, okay, which is greater than our S-max. So, our S, which is 850, is greater than our S-max, which is 260. Okay, so obviously, okay, we cannot use the 850. Okay, so we will use the 260. So the answer for the example number 2 is we're going to use a 10 mm diameter stirrup, okay, space at 260 mm on center. Ito po yung magiging sagot natin. Ito yung magiging spacing natin near the support. Okay? Sana may natutunan po kayo ngayong araw na ito for this example number 3. So next item is example. Okay, we were going to solve or we were going to design the whole beam. Okay, for the next video. Thank you very much.